In our previous lesson, we saw how we can read the input and print the output using scanf and printer. And now we also wrote a basic program to find the product of the two numbers. Now in this lesson, we will see in detail how we can use various arithmetic operators to perform calculations in our program. Let's get started by writing some code. I have already written a couple of lines here. First line at the top is a comment. A comment is ignored by the compiler. It's not treated as an instruction to be executed. To write a comment in a single line in C, we need to type into forward slashes and anything starting the forward slash until the end of the lines would be a comment. In the next line, I have written an instruction to include stdio.h library. This library gives some basic functions like printf and scanf are part of these libraries. And after that, I am writing my main function. Now in my main function here, what I wanted to do is I wanted to declare two integer variables named a and b, and I wanted to ask the user to input these two integers. So I am first printing a message on the screen, enter a and B. Then I'm using scanf to receive input in A, and just like A, I will receive another integer value in B. And now let's do some maths here. I'm first want to calculate sum of A and B, so I will declare an integer variable named sum, and after I have got A and B as input, I will say sum equals to A and plus B, and with these instructions I have calculated some of the values in E and B, and I have assigned it to these variables named sum. And now I wanted to write a printf to say A plus B equals whatever the sum is. Now next I wanted to calculate A minus B. I have declared a variable named different, and I am saying of equal minus a minus b, and once and again will be printing. So this my different. Next I wanted to calculate the product of b. I'm multiplying a and b with this expression. A asterisk b asterisk and is the symbol for multiplication operator, and the I'm storing the value in this variable named product. So with this much of code, we have asked the user to enter two numbers a and b, and then we are calculating and printing a plus b and a minus b and a into b. Let's quickly run this program and see what will happen. The program is asking me to enter a. Let's say a is equals to 10. Now it's asking to enter b. Let's say b is equals to 5, and now we have got some output here. As we can see, output of all the three printf cells come to a single line. This is happening because printf by default does not takes the cursor to the next line. We need to explicitly insert an end of line character to take the cursor to the next line. What I will do here is the end of the string constant in each of these printf call, type in backslash and then n. Backslash and n together is treated as a single character. Backslash n is called end of line character for a backslash n, and end of line character will be printed and cursor will go to the next line. So I will put backslash n in all three printfs, and now when I am running this program, output of each printf is coming on a separate line. In the first print of percent in the string constant will be replaced with the values in sum, and that's why we have a plus b equals to 15 printed here. 10 plus 5 is 15, and similarly a minus b, that would be 10 minus 5 is 5, and and a into b is 50. End of line character, which is also called a new line character or new line breaker, should be treated more like a command to be executed rather than as data it's inserted in the data, but it works like a command. It takes all the next following it to a new line. Okay, so with this much of code we are performing addition, subtraction and multiplication. Let's now perform division. Let's say we wanted to divide a and b. If I am dividing a by b, then I am not be completely divisible by b. B may be not be a factor of a. In such a case, we can show the result, the outcome of the division in two ways. We can either show result as a real number. For example, I'm dividing 9 by 2, then the result would be 4.5. There would be a fractional part, or what we can do is we can say that quotient of this division is this, and reminder is this quotient. It is basically the integral part of the result of a division. To perform division in my code here, I can use division operator. I will declare a variable named c here, and I will write a statement c equal a by b. That is my division operator, and now I will print this value. I have written a print a by b equal whatever is assigned to c after division. Let's equal to quickly run and see the output. This time I wanna say is a is equals to 9 and b is equals to 2. What I'm getting here is e by b equals to 4. We are getting the quotient. This is happening because a and b both are of type integer. We have declared them as int, and when division operator is applied to two integers, then only the integral part or the quotient is returned back. If you want the fractional part as well, then you need to declare a and b as variables of the type float or double float and double r types that are used to store and perform calculations on real numbers. What do now is in the declaration statement I will change this into to float. So now all my variables are of type float. Now in all the scanf and printf statements, the format string or the string constant should have placed placeholder %f instead of %d. %f is placeholder for float. Let's run this program now once. Again, I will say a equals to 9, b equals to 2, and see what we have got here. Data is being printed with fractional part. By default, printf is printing 6 digits after the decimal point. We can choose to print as many as we want. Let's say I wanted to print only 2 digits after the decimal point. Then instead of writing percentage f in my string constant as a placeholder, I will write 0.2 f percentile point 2f, and now only two most significant digits after the decimal point will be printed. If I am wanted 3, I will say 0.3f. Let's just put point 2f everywhere in all the printfs, and let's run the program now once again. Let's say a is equals to 9, and now because here we are scanning the floating point number or real number, we can also enter something like 9.0. I can have a fractional part in my input as well. Now let's say b is equals to 2. It's now mandatory to enter the fractional part. It is if it is 0, and this is what I am getting, all the values are being printed till 2 digits after the decimal point. There is another data type that can be used to store real number, and it's called double. So instead of using float here, we can could have used double with double. You get twice the memory or storage as compared to float. In a typical architecture, size of float would be 4 bytes or 32 bits, and size of double would be 8 bytes or 64 bits. If my variable are of the type double, then I need to use percent lf has placeholder in this format string pass to printf and scanf. Okay, now I want to come back to integers, and I want to talk about one or more operators, and this operators is called modulus operator, as we had seen earlier. Division with integer types and gives us the quotient. I will rename this variable c as quotient, and now I want to declare another variable named reminder. Modulus operator gives us the reminder symbol. For modulus operator is this character, this percent with the statement reminder equals a modulo b. We will get the reminder of the division of a by b. I will just print the reminder. Let's run this program and see what happens now. I will say a is equals to 9 and b is equals to 2, and this is what I have got in the last line. I have got 1. If I will divide 2 by 9 by 2, reminder would be 1. I'm writing the value only. I'm not writing something like a modulo b equals this. Actually, let's just print this like all other lines in this last print. Now I am writing a percentile b equals percentile d. Percentile d is my placeholder. Now when I'm running this program, I have not to got the percentile here in the output of the last printf. This is the happening because a percentile is treated as a special character by printing. It's treated as the beginning of the placeholder to print these characters using printf. What we need to do is we need to put 2 percentile together. If we will put 2 percentile together, printf will not look at the pair it context of the placeholder. As you can see, now we have got the output a percentile b equals to 1, or we should say a modulo b equals to 1. Okay, so now we know how to do some basic arithmetic in C. We can write an arithmetic expression and assign it to an variable once the expression is evaluated. The result will be stored in this variable in this statement. Sum equals to a plus b. This equals to sign is for the assignment operator. In right hand side of assignment operator, we have an arithmetic expression, and in left of this assignment operator we have a variable name. We cannot have anything else in the left of the assignment operator. It must always be a variable. In right, we can have a constant of variable or an expression. Here we have an arithmetic expression, and we have a really simple arithmetic expression here. We could have a really complex one with multiple constants, variables, and operators. I have written some more instructions here, and in all these instructions we have arithmetic expressions with more than one operator. We can write such complex arithmetic expressions, but we must understand how to create